Okay, well, I actually wrote a lot of stuff down that was totally wrong because I'm careless, it's late in the day, and I probably don't have enough blood sugar. However, let's see if we can get it right. Okay, P is a set of prime numbers. Prime numbers are the numbers 2, 3, 5, 7, 13, 17, 19, and so forth. All the numbers that are divisible by themselves and by 1 and by nothing else. Okay? And more specifically, they're divisible by 2 numbers and no others. One of the numbers is always 1, and the other number would always be itself. Which means that 1 isn't a prime number because 1 has only one divisor, which is itself. All the rest of these have 2 divisors. So, whether you understand that or not, right there's a list of the prime numbers. And if you happen to list 1 in the prime numbers, we haven't gotten to that topic yet, although you certainly should know it. But I probably wouldn't penalize that at all. And if you accidentally wrote down some weird number that looks like it ought to be prime but isn't, like maybe 93, although that was pretty easy to determine, I'd not be too strict on that, as long as you got the general idea and manage to list these things. Now, the problem that you have is P cross AB, okay? But without thinking, I wrote down the members of AB cross P, and I went quite a ways into the problem. I don't want to have to redo that, and you learn just as much by looking at it this way and then thinking through what you would do for the problem as stated. So I changed it. I'm doing the problem AB cross P, but your sheet or your document asks for P cross AB. Okay, well, typical elements of AB cross P, the Cartesian product of 2 sets, is a set of ordered pairs where the first member of the ordered pair is from the first set, the second is from the second set. Okay, well, the first set consists of A and B, the second set consists of all these prime numbers. And of course, prime numbers are infinitely many of them, they go on forever. Okay, typical elements of AB cross P, A7, A's in this set, 7's in the set P. B19, B's in this set, 19's in this set. B3, again, B's here and 3 is here, and so forth. Okay. Now, how could we list the elements of this set, of the set AB cross P? We might start by listing the elements that start with A. Okay, A1, A2, A3, A5, A7. Probably ought to list A11. And incidentally, when I say I look the other way when you don't get all the elements right, 11's in there. I didn't write it down. Okay. Still, you get the idea that we could write the set down like so. Except that we're done. We're stuck. This process, this pattern can go on forever, and it doesn't get any of the elements, or B is the first, any of the elements of the cross product, the Cartesian product, where the first element is B. So it looks like we're stuck, but we're not really stuck, just sort of stuck. Okay, we can cheat our way out of this. It's not even really cheating. We can just take the union of this set with the set of all the ordered pairs that start with B. Okay, that's perfectly legitimate. There's a better way to do it, but that's going to work. And then we can number the elements of this set. Number 1 here, number this one, number this one, this one. 1, 2, 3, 4, 5, 6, 7, 8, etc. It's clear that we're going to put a single number, single counting number with every element of this set. Okay, and there's going to be a 1-to-1 correspondence between counting numbers in the set AB cross P. Now, we could have written down AB cross P a little more cleverly without having to use a union. Let's just do A2 and then do B2. Okay, so we've got both A and B paired up with 2. And then A3, B3, A5, B5, etc. It's clear that this set, this pattern continued, is going to eventually get to any element we wish in the set. Okay? So now we can number this. 1, 2, 3, 4, 5, 6, and so on. And there's a numbering scheme. I'm not going to ask you to necessarily come up with a computational scheme, but for this one, you could. Wouldn't be too difficult.